Welcome to Koushal Chemistry online classes. Today I would like to discuss few words regarding chemical kinetics. In this chemical kinetics, the most important subtopic is enzyme catalysis. Okay, enzyme catalysis. Enzyme here, enzyme catalysis nothing but here enzyme can act as a catalyst. Enzyme can acts as catalyst. Enzyme can act as catalyst. Okay. Here the enzyme increase the rate of reaction. Enzyme enzyme increase the rate of rate of reaction. Enzyme increase the rate of reaction means this decreases the activation energy. Decreases the activation energy. Activation energy. Enzyme catalysis nothing but enzyme can act as a catalyst. The rate of reaction is increases and then the rate of activation energy is decreases. Okay. What is the chemical equation is present in enzyme catalysis? What is the chemical equation present in enzyme catalysis? It is a two-step reaction. In one step, the formation of intermediate, and the second step is this formation of this formed intermediate is converted into product. Okay, enzyme plus substrate. It is a two-step reaction. In this first step is equilibrium reaction. First step is equilibrium reaction. This is the enzyme substrate complex. This is the intermediate. Intermediate is what? Enzyme substrate complex. This enzyme substrate is decomposed into products. Okay. Products plus enzyme. Okay. The rate constant of formation of intermediate is K1 into ES, and the decomposition of intermediate is K inverse into ES. Okay, and the formation of product, the decomposition of intermediate is equal to K2 into ES. Okay, this is the two-step mechanism. Two-step mechanism. In this, first step is what? First step is what? This one is the first step. Okay, formation of enzyme substrate complex is nothing but formation of intermediate. Enzyme plus substrate which says to what? Enzyme substrate complex. Enzyme substrate complex. This is the first step, and second step is nothing but the decomposition of intermediate. Means enzyme substrate complex is decomposed or dissociated into product. K2 products plus enzyme. Okay, it is two-step reaction. Then the rate of reaction is depends upon what? K2 into ES. Means the rate of reaction is depends upon enzyme substrate complex. Rate of reaction or velocity of the reaction mu is equal to K2 into enzyme substrate. First of all, we have to discuss few points regarding enzyme. Okay. In enzyme, initial concentration is equal to what? E naught. Initial concentration of enzyme. Initial concentration of enzyme. E naught is equal to what? Initial concentration of the enzyme. Then ES, you know already, ES is nothing but enzyme substrate complex. Enzyme substrate complex here. Then E is equal to what? E is nothing but free enzyme. Okay. E naught is equal to what? Initial concentration of the enzyme. ES is equal to enzyme substrate complex, and E is equal to free enzyme. Okay. Then we want here enzyme only. Then enzyme E is equal to enzyme concentration E is equal to E naught minus what? ES. E naught minus ES. Okay. These are the most important. The rate of reaction is depends upon K2 into S. Okay. Here E is equal to what? E naught minus ES. Here, for example, in simple reactions, the rate of reaction or the order of the reaction it depends upon the molecularity. Here, 2-step, 3-step means complex reactions, chain reactions, different reactions. We have to apply steady state approximation principle. We have to apply steady state approximation principle. Okay, what is steady state approximation principle is nothing but the rate of formation of intermediate is equal to 0. dES by dt is equal to what? 0. Is nothing but the rate of formation of intermediate. The rate of formation of intermediate is equal to what? The rate of decomposition of intermediate. Okay. What is steady state approximation principle? The rate of formation of intermediate is equal to the rate of decomposition of intermediate or dissociation of intermediate. Okay. And then here 2-step. One is formation of intermediate is nothing but K1 into ES, enzyme substrate, and decomposition of intermediate involves 2 steps. One step is K inverse into ES and K2 into ES. Means here formation is 1 step and decomposition is 2 steps. K1 into S into E is equal to what? K1 into ES is equal to K2 K inverse into ES plus K2 into ES. K inverse enzyme substrate plus K2 into enzyme substrate. These are the 2 steps. Here we know already what? E is equal to 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 enzyme concentration is equal to what? Already explained. Enzyme substrate concentration is equal to E naught minus ES. Okay. Free enzyme is nothing but initial concentration. It is enzyme substrate complex. Okay. Here is substrate enzyme substrate complex. Enzyme concentration substituted in this equation. Then what happens here? K1 into S into E is nothing but E naught minus ES. E naught minus ES is equal to K inverse ES plus K2 into ES. K2 into ES. Okay. And then here K1 substrate E naught minus K1 substrate E naught minus K1 substrate ES. K1 substrate ES. Then K inverse ES plus K2 ES. Okay. Understand? And multiply this one. Then this step is appeared. Then this minus is going to this side. Then it is converted into plus. K1 S E naught is equal to what? K1 S ES plus K inverse ES plus K2 ES. K2 ES. This is the reaction. In this, you have to common what? K1 into ES, K inverse into ES, K2 into ES. Okay, ES is the common. Then ES is the common. Then K1 S plus K inverse plus K2. Okay. Then here we want enzyme substrate complex. Which one? Enzyme substrate complex. We want enzyme substrate complex. ES is equal to enzyme substrate. ES is equal to what? ES is equal to K1 S E naught by K1 substrate concentration, initial enzyme concentration by what? K1 into S plus K inverse plus K2. K inverse K1 into S plus K inverse plus K2. But the rate of reaction is what? Rate of reaction is equal to what? Rate of reaction is equal to what? K, already I explained K2 into ES. K2 into ES. Substitute ES is equal to, substitute ES in this equation. Then rate of reaction V is equal to what? K2 into K1 into S E naught by what? Here K inverse plus K2 plus K1 into S. You have to write like this. Okay. then it is multiplied by both numerator and denominator by K1. A is equal to K2, K1 means here K1 is then K2 into substrate V0 minus K inverse plus K2 by K1 plus K1 cancel. Then what happens here? Substrate. Both numerator and denominator it is multiplied by what? Both numerator and denominator multiplied by K1. Then the reaction is K2 into substrate V0 by K inverse plus K2 by K1 plus substrate. Here most important thing is K inverse plus K2 by K1 is equal to what? Km. This is the what? Michaelis Menten constant. Km is nothing but Michaelis Menten constant. Okay, Km is nothing but Michaelis Menten constant. Then the final reaction of enzyme catalysis is the rate of reaction for enzyme catalysis is nothing but what? The rate of reaction or velocity of the reaction nu is equal to what? K2 into S into E naught by what? Here K inverse plus K2 by K1 is nothing but Km plus S. This is the reaction of enzyme catalysis. This is the reaction of what? Enzyme catalysis. This is the very important reaction. So many competitive exams asked from this different types of questions asked in different types of examinations. Okay. K2 into S into E naught by Km plus S. This is the final equation for enzyme catalysis reaction. Okay.